This is a geometry lesson for day 2 of topic 12, section 1. When we look at this, we're going to talk about independent and dependent events. So first of all, as you see on your note page there's 3 different events that are listed up at the top. So given the following event, determine an event that is independent and an event that is dependent. So let's look at these. First of all, the event that I draw a card and it is an ace. That's going to be a 4 out of 52. There's 4 aces in a deck, 52 cards in the deck of cards. And so that's a 1/13th probability. That's just that event. Now, an independent event from that would be I can roll a dice and get a 6. Now that's independent because if I roll that dice, it has nothing to do with picking a card out of the deck of cards. A dependent event would be as I pick a second card and get an ace. So if I've already picked an ace out of the deck and I go back to the deck and pick another and want the probability of picking another ace, so I pick a second ace out of the deck. Notice that this one is dependent because now there are only 3 aces left in the deck of cards and there's only 51 cards left. So the probability is different in this case. So that's a dependent event. Now let's say our event then is 90 degrees outside, okay? An independent event would be that I'm gonna go to sleep tonight. So I will go to sleep tonight. Okay, I'm going to sleep tonight whether it is 90 degrees out or whether it's not. Now it might affect the comfort of how I go to sleep, but the fact that I'm going to sleep, that's an independent event. Now a dependent event would be that I'll turn the air conditioning on. That depends on how hot it is outside. If it gets very hot, that's gonna raise the probability that I'm going to turn on the air conditioning. So I will turn on the air conditioning, on the AC. So the probability that I will turn on the AC definitely rises up as the temperature gets hotter outside. Okay, now the last one we have here, the third one listed, is if we select a day of the week and it is a Friday. Okay, that would be, notice that would be a 1 out of 7 if I pick one day out of the week. So this would be a 1 out of 7 event. Okay, an independent event will be that I will eat dinner. Okay, I don't have the habit of not eating dinner whether it's Friday or not. So I will eat dinner whether it's Friday or not. So that's independent of this. But on the other hand, it does influence whether I go to school. It's more likely for me to go to school if it's a Friday than say if I had picked off a Saturday. On a Saturday, I probably wouldn't go to school unless I had, say, a softball game or something. So the probability would go up if it's a Friday over, say, going to school at that time. All right, so when you have 2 events, A and B are independent events, you look at these events that are independent. They're independent if and only if, meaning it's if this, then this, also if this, then that. If and only if the probability of A and B happening equals the probability of A times the probability of B. Okay, so you can multiply those together if you know that they're independent events. Okay, let's talk about figuring out. So this can help us. If we know that they're independent events, then we can find the probability by multiplying the probabilities. If we don't know whether they're independent, but we do know their probabilities, multiply the probabilities together. And if that multiplication equals the probability of them together, then they are independent, so it can go both ways. So that's going to lead us to the examples down at the bottom. Let's go ahead and do those. So let's start over here. right, so example 1 here, let's talk about that one. Example 1 says the probability that Mr. Wieringa wears his glasses is 0.95, okay? So I'm going to put probability of glasses, Mr. Wieringa, equals 0.95. And the probability that Mr. Wieringa gives a quiz on any day is 0.2. Because Mr. Wieringa usually gives a quiz about once a week, once out of every 5 days. And so that's about 0.2. So let's see what the probability is that Mr. Wieringa wears his glasses and gives his quiz. We know that probability is going to, so both glasses and quiz, we know that that probability is 0.8. Okay, through observation, we figured out that that's the probability. Let's see if these are independent. Now we know the probability of them individually, we know the probability of them together. How we determine whether they're independent is we take and we multiply these two. So if we take 0.95 and multiply by 0.2, what you get when you multiply those together, you get 0.19, okay? So are these independent events? They are not. I mean, it's very likely that glasses and quiz interact a little bit, because if Mr. Wieringa forgets his glasses, he might not give a quiz that day, as an example. But you don't have to reason that out. You use the probability that this says, since these two are not the same, they're not independent. Okay? So that's how you check it out, if those two are the same. So the answer is no, they are dependent. We'll actually use the word dependent on each other. Okay? So let's do example 2. Example 2 says that the probability of rolling a 2 on a dice and selecting a 2 from a deck of cards. So I'm going to put probability of 2 on a dice and 2 from a deck of cards. Let's say that's equal. We know that probability is equal to 1 over 78. Okay, let's see if we can determine if these events are independent. Well, we know we can figure out what the probability is of a 2. That's 1 out of 6 on a dice, because there's 6 numbers on a dice. The 2 is only one of those numbers. So the probability of a 2 on the cards, there are 4 2s on the card, okay, and there are 52 cards, and that reduces down to 1 out of 13. Now we take those two, and if these two multiply together to give me that, then they're dependent. So let's try 1 over 6 times 1 over 13, and that gives me 1 over 78. As you multiply 6 times 13, you get 78. These two are the same, so it's a yes. So they are independent. Okay, so those two events are independent of each other. All right, so let's do example 3. Now we've got several parts to this. Let's do each part. First of all, it says there are 3 red marbles. Let's do a little bag over here of marbles. Okay, so there's 3 red marbles. And we've got then, looks like we've got 6 green marbles. So let's draw green marbles. So 6 green marbles. So 1, 2, 3, 4, 5, 6. And then we have, in this case, we have 1 blue marble, okay? So a total, if we add all those up, we have 10 marbles in that bag, okay? So we've got, if we look at the probability here, the first question is, what is the probability of selecting a blue marble? So first one, probability of blue would equal 1 possibility out of the 10, so 1/10. If you want to list it as a decimal, you put 0.1. Okay, if the marble is returned to the bag, so we now have the full bag again, so return that blue marble to the bag, What is the probability of selecting a blue marble on the second draw? So we'll say second draw here. It's still 1 out of 10 because there's one blue marble still in the bag and 10 total marbles because we returned that blue marble. Now, what if the marble is not returned to the bag? So I'm going to now, notice what I'll do is I'm going to erase the blue marble. So we now have only 9 marbles in the bag, all right? So now in this case, it's not returned. So I'm going to do it over here, say not returned for this part. Okay, that blue marble is not returned. So what's the probability of a red or a green or a blue? So if the marble is not returned to the bag after the first draw, what's the probability of drawing a blue marble on the second draw? So notice that, let's just talk about all of them. The probability of a blue would be 0 out of 9 because there's no blue marbles left in there. Probability of a red, just by the chance that that were to be asked, there's still 3 red ones in there out of the 9 now. So that would be 1/3. And the probability of the green would be that there's 6 green out of the 9. So that would be 2/3 as a possibility. So those would be all of the, if we had picked the blue first out and didn't return it, what we would have. So if the marble is returned to the bag, they are independent because it's the same probability. But if it changes, if we don't return it, so it's not independent if we do not return, if the blue marble is not returned. Okay, so when we're talking about dependent or independent, you can, if you know they're independent, you can multiply the probabilities. If you're testing to see if they're independent, take the two probabilities, multiply them together to see if it matches the probability. If it doesn't, then they're not independent, they're dependent on each other. If it does matches, then they're independent from each other.